So I'm going to talk a little bit about cloud-native GraphQL, and this is mostly stuff that we've learned from our users, especially some of our larger users, when they've been taking GraphQL and trying to merge it with this idea of the cloud-native transformation or the digital transformation journey that they're going through. Hasura is, a lot of these ideas that I'm talking about are not the right way of doing GraphQL or the only way of doing GraphQL. They're just ideas, right? Like any other technology, what works for you is what works for you. If you were all stuck about the right way of doing REST, nobody does the right way of doing REST. Thankfully, it's like, I think it's like a 20-page long spec. All right, so to kind of get started with this, as we all know, GraphQL works really well with the monolith, right? And this is primarily because it is a shared type system for your entire API. That makes sense. You have lots of types. You write, you collaborate on code together. You write, if there are conflicts, you deal with that. You kind of look at the whole type system in one place. Like the notion of a type system makes sense on a single code base. So reads and writes can reference the same kind of type graph. And especially when you think about subscriptions, that kind of brings in a lot of state that is ephemeral or that might need to live across invocations or across requests. And that becomes much easier to think about in a monolithic system, right? So on the other side, while this whole GraphQL thing is happening, a lot of other people are doing this whole cloud-native thing, right? So what is this cloud-native thing? The cloud-native thing is basically this movement towards kind of like first-class containerized microservices and serverless compute. And these are not two independent things. It's kind of, it's a spectrum, right? So you have, I'm not sure how many of you have tried out things like Cloud Run, where the idea is that it's kind of like a serverless function that gets invoked, but it also stays around for a few minutes, and it's actually a container that runs as a microservice, right? So it's kind of blurring the lines between what you would have just thought of as a microservice and what is serverless. But one of the key ideas behind being efficient with what runs on cloud native is also being stateless, right? So the reason why people want to move towards things like this, independent of what is happening in GraphQL world, is because it allows teams to have end-to-end ownership of their own code and own the entire deployment lifecycle as much as possible, right? Which is not new, which has been a long journey that we've been doing over the last 15, 20 years, ever since we moved to the cloud and then became cloud native. And this works really good, really well for a business, because the idea is to say, hey team, hey developer, go do your own thing. Don't talk to each other because I don't care. I mean, I'm a business. So just go and build stuff, right? And which works well, which is why people talk about the Conway's law and having microservices and stuff like that. The desirable properties of things that are inside microservices or serverless functions are, one, that they should be stateless. And stateless means that you don't actually care about a particular running instance of your service or serverless function. They're cattle, not pets, is a common way of putting it. So you don't name them. You don't give them any kind of like, this one has a particular name or a particular IP or is a special instance that has these special properties, none of that. You want them to be quote-unquote elastic, which means that you want to exploit the fact that you're actually running on the cloud, so you want to be able to scale up and scale down quickly. And another idea that works well with both of these is being event-driven. So you want things to happen when events happen, right? And this is nice as well, works really well with the serverless, like per invocation style compute that is also happening, right? So bringing these together, though, in a native way, right, is a little bit hard, as is not surprising, right? So for example, for queries, and I'll go into detail with each of these a little bit, but if you think about queries, you need to have a shared type system across different services or APIs, and need to have semantic relationships across them. You don't even like, I mean, how do you even think about this? You're suddenly defeating the entire point of going to microservices, right? If you force people to start collaborating with each other. Or if you think about mutations, increasingly mutations and writes and workflows are driven through kind of like an event-driven workflow. And so let's say you have an event and you get a response event, and now there's a response event and there's a response API, but like relationships across them, does that even make sense? You know, it becomes a little bit wonky to think about, right? And then, of course, subscriptions, which are super, super, super painful. You need to actually hold a WebSocket connection open with something that wants those events, right? And if you have serverless and cloud-native things that are going up and down, what is even holding the connection, and like what entity even knows to send what event to whom, right? All right, so to dive deeper into these with examples. So let's say you have like a profile service that has like a customer type, and then I'm using a Stripe API, which is not a microservice that I own, but an external service that I'm using, which has other information, other data, and I kind of want to bring that together into a GraphQL API, right? How do I think about doing this? One of the common approaches, which has resulted in like the GraphQL gateway kind of approach, is to have schema stitching, or to say, and these don't have to be GraphQL servers, but the idea of just like stitching together systems, right? So you say you write some code, or you try to make it a little bit automated. You maybe have like an internal DSL that makes it faster. Maybe you just have metadata, like what Hasura does, and then you kind of start trying to bring these systems together. An evolution of that we've seen with the Apollo folks is the GraphQL Federation, which is trying to make this process entirely automated. One of the interesting things to think about there is it kind of requires the upstream servers to be GraphQL servers and implement the Federation spec as well, which is a little bit interesting because those services themselves might not be GraphQL services, and there's a little bit to think about there. All right, so that's kind of what the read problem is. On the right side, this is a particular, I don't know, how many folks have used and played around with stuff like Knative eventing? Has anybody played around with Knative eventing? All right, awesome. All right, okay, cool. But stuff is becoming event-driven. It's one of the Gartner top quadrant thingies for the year, whatever. So let's say, for example, I have this e-commerce thing, and I'm placing an order, and then that is a GraphQL mutation for the client, but that's actually an event for some other service, right? It's not necessarily an API call, and then I get an event which is a response back on the queue, which can happen asynchronously, and then when that happens asynchronously, maybe the client doesn't want just the order, but the client might also want the associated tracking info that this particular order has, which might be getting pulled in from a different service altogether, right? So it's kind of weird to think about of like bringing those two things together as well, right? And that's kind of one of these problem areas when it comes to event-driven logic, right? And then of course with subscriptions, the problem is fairly easy to describe. Let's say your order had an update, and you want to send this update to the client, but there's nothing there in the middle. Let's say, for example, if you're serverless, like what is even there to figure out whose order this is, whether this person is even connected, and to send them something, right? So, and there's lots of like subtleties there, because it's not just about having and maintaining a persistent WebSocket connection, but it's also about understanding the authorization and who this event is for, right? Is it a fan out? Is it like one event that I send to multiple people simultaneously? Is it just for one particular person? How am I consuming from the event queue? Is that subscription system horizontally scalable and it can read events from multiple places? Complex, not fun. All right, so one of the architectures that's emerging, and this is kind of what we work on with some of our users, is to have this kind of engine in the front, which not very surprising, which is as declarative as possible, that you use to try to create relationships across APIs and events. So that means you have predefined contracts with specific types of backends that your organization, that your teams have, right? And these could be services, these could be external APIs, these could be serverless functions, whatever, right? And then on the other side is to kind of move in more into the CQRS event sourcing style stuff, which is to say separate those reads from the writes entirely, and have almost like a Flux style architecture for your backend, which has been around for a really long time. It's just kind of seeing renewal and popularity again, which is that you have a native integration with some kind of an event store, so that these mutations are actually more like CQRS commands that are kind of going into your event store, triggering something, maybe talking to your microservice, and then coming back. And then because that layer has a contract with the event store, hopefully you can send that back to the client when the time comes. And then for subscriptions, to route that through a central event store, and this could be completely different, doesn't have to be related to the CQRS stuff, where you kind of have a very specific way of doing the mapping of who owns this event on the client side, right? Or who needs to be sent this event on the client side. And that auth mapping and also the WebSocket kind of client connection mapping is something that needs to be built in, in a way that works for the setup that you have. So, so that's kind of one way that we've been seeing this come together. And I guess in a lot of different places you have different ways of kind of doing the same thing, right? So what we're doing at Hasura along these lines, right? Like two specific things that that I'd like to mention. One is this notion of what we call remote joins. So the part that if for those of you who've heard of Hasura, you would see on the left is Hasura is essentially a metadata engine, and what it does is it kind of is very similar. The metadata is very similar to the repos stuff that Sasha talked about, which lets you map data models into something that the clients want. And also has a role-based rule engine. That's what the metadata has, which is similar to the rule stuff that Dina talked about. And powered by that, Hasura converts the data models into a GraphQL API. And then we use this notion of being able to do joins, just like you do in a database, to join across other things. And these could be things like a Stripe API, or these could be things like a Swagger API or a gRPC API or whatever you want. But in this case, for example, the example that I'm going to show you, let me just put this, escape this. I had to get myself a new touch bar Mac from the older keyboard Mac because I was flying in from India a few weeks ago, and they've banned those Macs. So I just got myself a new laptop. That's how I roll. All right, okay, cool. So this is what a graphical kind of console looks like. And I just have a customer kind of table thing going on, right? And I have this notion of a Stripe customer ID. And then I have this cool tool that you might have heard about called OneGraph, which is incidentally built by Sean, which gives me a GraphQL API over Stripe, right? And what I do is in my metadata configuration, I say, hey, you know what? There is this kind of semantic relationship between what I have here, like a column that I have here, and a field and a filter value that I have there, right? And then what you can do is you can start making calls that unify that data and bring them together, right? So that is the Stripe API, and that email is coming in from our database, right? So, so that's kind of one way that this queries across different data sources and the way that comes together. All right. This is something very interesting that, that we've been working on. I don't know if the text is very clear, but we call this GraphQL actions, and these are basically event-driven mutations. So what you see in the black kind of box, I don't know if the contrast is good enough, it's a little function that it's a REST API. It takes in a name and an email, and it returns a user ID, right? In the middle, maybe it does some stuff with the database, it does some validations, maybe it dispatches another event to say, send out a welcome email because we've created this user. And then it returns just a user ID because the user ID was created. But the mutation that the client sees is the create user mutation that actually can query the entire graph, the entire user graph, right? And that's because we're able to kind of link the user ID that comes back from the event payload to the rest of the graph, wherever that graph comes in from, right? Might come in from an external API, your database, your other REST services, or whatever. And this is very interesting for a demo example that I'm going to show you soon. But so here, for example, I'm querying into the user graph. Maybe I had some default groups that every user has that I also get as a response to the same mutation, right? All right, so this leads to a fairly interesting architecture that is gradually becoming possible, which is this idea of having like a Flux style architecture all the way from the front end to the back, right? So let's say, for example, you run a mutation. The mutation triggers an event, you go put it into your event system, it goes and runs maybe a bunch of microservices, serverless functions, whatever. They keep going, interacting with events. Whenever that circuit completes, you send back a response to the client. The nice thing here is that you can toggle this thing in the middle that you have. This can toggle between an async and a sync behavior, right? So you can say, I want to keep this synchronous. So we'll actually pretend that this mutation gives you a synchronous response. Or we'll just say, hey, here's a mutation. You ACK it with like whatever an ID. And then you can subscribe to the changes in your order workflow as they happen, right? Which, of course, depends significantly on subscriptions working well, right? And so the other thing that we've been working on is scalable, reliable subscriptions, which is an interesting problem to solve. And so, for example, we did this benchmark a while back where we create 1 million events in a Postgres database. And each of those events are relevant to different users. And so you have 1 million different connected apps. This was hard to benchmark. There's an open source benchmarking suite that we built for this as well. And everybody kind of gets those unique events as they happen, right? And the reason why this was possible to build is because we exploited a lot of specific properties that you could, one, by knowing that you can read into the way Postgres events are, you can read into the database, you can refetch queries optimally, you can do stuff like that. And also by having a authorization DSL that helps you map events to the right kind of clients, right? So for making sure that that middle layer is as cloud native as possible, that means that that middle layer, which is in our case an instance, a series of Hasura GraphQL engines that are running, if they need to be auto-scalable, then the way that they talk to the event store, fetch data, decide who to send it to, it needs to be fairly peculiar, right? Or particular and peculiar, and then send that out to the client. So this is an interesting blog post. I forgot to link it here, but if you just search for 1 million GraphQL subscriptions Hasura, we have a detailed architecture blog post on how we've done it, which should lead to some interesting ideas for how you can build these kinds of subscriptions yourself. So with that said, before I proceed to a quick demo, what I want to show you is this seems like a little bit of a cop-out because, I mean, this is not cloud native anymore. You put a monolith in the middle, right? True. But the way we call this or think about this as cloud native is that there is a lot of effort that one should put into making that middle layer as auto-scalable as possible. And this has been interesting, mostly just tactically, because this GraphQL engine in the middle, for example, the way we built it is CPU bound and auto scales really fast. Each instance is highly concurrent and can be multi-core. So that means you can do a lot of the per request caching across states, doing optimizations that would be possible in a monolith, but making sure that that piece can auto scale out really easily, right? One of the things, for example, that is a pain when you auto-scale things is that you can't have a memory-bound process. They don't auto-scale well. So in our case, for example, it's a CPU-bound process. So you tweak the way you configure it to be CPU-bound so that whenever you hit 60% CPU, you can auto-scale it so that by the time it hits 80% CPU, you have enough. You have another instance that goes up. But again, all of that only works if you can create very specific contracts with the backend event stores. Otherwise, this whole scale-out piece is just not going to work. So this piece in the middle ends up being an auto-scalable monolith and not quite cloud native. But it works. All right, so I do this demo, and I keep refactoring and rebuilding this demo every time we build something new just to show what's possible. So you can kind of whip out your phone, scan that QR code, or head to bit.ly/3factor app. And let me see if I can bring this up. All right, so what you should see is a little order app. It's a little e-commerce app. Let me bring that here. All right, cool. So I'm going to zoom that in. So I'm going to place an order here. So let's say Sean Grove, super hungry, and he wants to place an order. And he's like, I want to eat a donut with mangoes and pumpkin pie. And so you place an order. And now all of the business logic behind this, which is like the order validation, the payment stuff, the payment validation with Stripe, the restaurant approval, the driver assignment, this is all business logic that's happening. In some cases, it's running on AWS. In two of them are running on Google Cloud. And all of this is running with subscriptions, so you can see updates happening on the left and the right? So now, for example, I'm making a payment through this card that I have, which might be coming in from an external API. And then you can see that change on the right? So this, I can close this tab, come back to this tab. It doesn't matter. Wherever I left off, I continue from there. And on the left, we can see that some of you have placed orders, and some of you have not paid for your orders, which is why you can see this gap in the middle, right? That's people who've paid, It's proceeded. These are people who've placed orders, and these are people who've paid. So free food. I see what's happening. All right. So this is nice because the developer experience here was doing data modeling, writing business logic, and that's it. And not caring about anything else because everything else, the plumbing for everything else, is kind of done by a different team or a different tool or whatever, and that works. Another reason why this works really well, and again, some of you might have seen this demo before, but this is an example of where a colleague of mine who recorded this video went and placed 1,000 orders in one shot, right? So 1,000 orders get placed, massive spike. All of the validation functions are going crazy. AWS is like, oh, spin up containers, spin up containers, spin up containers. And then you can see that like all of those validation functions are running. It's nice because you'll see the UI start flipping into, with the order validation start becoming a checkbox. And that's good. And so now 1,000 orders are validated. Now we're waiting to pay them. So we pay all of them in one shot, like good people. Massive spike again. And now we're going to simulate a failure, right? And this is why people want to do event-driven stuff. I went and throttled on the AWS console, which basically means that it's kind of like a network failure that happened, right? Let's say our event delivery system can't connect to the microservice or whatever. There's a failure for that, like the third microservice that is in that event loop, and people are panicking. Everybody's like, oh my God, what are we going to do? People are not getting their orders. They're hungry. They're calling the SREs, and they're like, okay, let's figure out where the LAN cable disconnected. They're running around, and they're like, oh, where's the LAN cable? I'm hoping that I'll get to the LAN cable soon on the video. Right? But everything's blocked, and so that's fine. But then I go back to the AWS console, and I unthrottle it, which is like plugging the LAN cable back in. And I hit save. Let me hit save. All right. And as soon as I hit save, which is like the cable plugged back in, everything kind of just picks up from where it left off, right? Because everything was events, everything was stored in a queue. And again, as like transient failures is just easy. You don't think about it anymore, right? As a developer, it's just like your system just takes care of it, which is the dream world that we all want to be living in. So that's kind of the power that these kinds of systems give you. The world is still a long way away from, not a long way away, but still quite a way away from putting a lot of this into action. But a lot of this starts becoming possible without having this video history. Let me go back. Right, starts becoming possible with kind of architectures like this. All right, so that's it from my side. I can take a few questions. We are also hiring for senior Haskell roles. We're moving our Reason to React. We're moving our React code base to Reason. We're big functional typed fans. So if you're a senior React person or you're a React person looking at getting into Reason, please do apply. And a bunch of other profiles as well. Please do check it out. I'm Tanmai Gopal on Twitter. If you have any questions, I can take them. Thank you.
Any questions? I'm going to have one. I'm curious about, so Hasura runs on top of Postgres. You mentioned 1 million concurrent requests to that. How do you even approach it? Postgres will lock up at a number of connections.
Yeah. The very, very long answer, but there we go.
Can you tell me to Google it?
Yep, exactly. This is it's a long blog post with lots of like discussions of trade-offs, architectures, and whatever. But the quick answer is that it's a bunch of interesting optimizations that are kind of like waiting for events to happen in the underlying database, plus doing a lot of smart refetching of state. And the way we're able to refetch state is we're able to refetch state in one database query, not just for the live query that you requested, but for like 10,000, 15,000 clients at the same time. So that means that in one DB query, when people are usually making one query to fetch like join across maybe their GraphQL query, we're doing that one query to fetch across 10,000 clients at the same time. And that lets us pick up a lot more from the underlying system. And this becomes a lot more interesting because, especially with the Postgres ecosystem, because the Postgres ecosystem itself is going through this new revolution, right? The folks who built the data layer at Facebook, they came out and did a database called Yugabyte, which is distributed Postgres that scales to terabytes, petabytes, just speaks Postgres. All of this works. I demoed this just about a week ago at a Distribute SQL Conf. And this just works. This just works at, not with just one Postgres with a million updates, but you have like Postgres databases spread out across of the globe, events happening everywhere, and GraphQL subscriptions going to people, and everybody just seeing real-time stuff. So, works so far.
I'll ask one more question if there's no question.
Sure. You mentioned you're moving from React to Reason.
Mm.
It's a little off topic, but what's the motivation behind that, and how's the GraphQL ecosystem on Reason?
So, yes, two questions, a lot to unpack. Well, first is we're moving from React to Reason because our JavaScript code base has become very large. And as a startup, we don't believe in testing, which makes it really hard, which makes it really hard to maintain a React code base that works. It's held together with Cypress tests right now, like just integration tests that work, which is very different to a server, which is in Haskell, which is like really good types. There's really good tests. There's no useless tests that end up checking for types, but there's like actual tests that test for like correctness, and we miss that experience on the front end. And so for us, it was deciding between TypeScript and Reason. And we're not sure yet 100% about moving to Reason because it's like Reason code is 10x better than TypeScript, but like the TypeScript community is like 100x or maybe 1000x of where Reason is. So that's kind of the trade-off that we have to evaluate. So that's what we're thinking about. But mostly it's so that our developers can move faster, test less, and write more features. On the other, the Reason ecosystem around GraphQL, I'm not very sure, but Sean can probably answer better to that. Our UI does not use GraphQL. Back in the day, we'd invented our own data access language on databases. I'd done the first version on Mongo, then we changed it to Postgres, which used to be actually JSON. And the API was like type, select, fields, array of fields. And we were like, this is our version of GraphQL. And then GraphQL came along, and we were like, oh, no. Ours is better. We tried like, oh, we're the best, we're the best. We tried that for like a few months, and then we were like, no, we'll switch to GraphQL. But our UI still ends up using our JSON API, which we still maintain, because dynamic queries in JSON are just infinitely easier compared to GraphQL, right? Like you can compose queries, you can build those queries at runtime, which is what our UI needs to do because it's an admin UI, right? Those types themselves are not known at build time. Those types are created at runtime. So being able to dynamically compose queries, like GraphQL fragments are not fun to compose together. But like a JSON object and a JSON query, that's easy to kind of build at runtime. So we still stick to our JSON API. I realize I should have said none of this, didn't help with the hiring pitch, but we're going to switch to GraphQL. We're going to switch to GraphQL. So that's what we're going to do. All right.